Hello everyone. I'm Dr. Ansu Sahu, Research Associate, and currently working as a under the supervision of Professor I. Ibrani. In today's lecture, we are going to discuss about the triboelectric nanogenerators. So, the name signifies it is nanogenerators. Means it generates the energy in the form from nanostructure, from the nano level to micro level. Why it is called triboelectric? Because it transfer the energy from it transfer the energy from triboelectric applications. If we, I think everyone has faced that electric shock, the static shock during the winters with our sweaters, or we can say with the comb and then papers. That when we used to rub our comb with the hair, so what will happen if we take that comb to the paper? So both will get stick. So that is why, because there will be a charge developed during the rubbing on the hairs, so on our comb, and when we and when we touch with the papers, so paper is having a negative charges. So when both the charges will come in together and they will get transfer each other and it will get stick. That is again the principle is same. That principle is also called triboelectric nanogenerators. Here we will see the principle of triboelectric generator, then how it is performing and what kind of energy it can harvest from our surroundings. So, so triboelectric required two different surfaces. One is having a charge affinity and one is having charge avoidance. So those who one is having a positive charge and one is having negative charges. So when this positive charge and negative charge come in contact, so what will happen? So if they will come in contact, the positive charge and negative charge will try to transfer to other surfaces. So because of this transfer of charges, the electric current will flow in the outer circuit. So we will see the principle of that triboelectric energy. So here blue one is our positive charge, tribo-positive surfaces, and pink one is our tribo-negative surfaces. So and we have connected with our external circuits. So once we will make closer to each other, so what will happen? The charge transfer will take place because of its nature. Because blue one is having a positive charge efficiency and the pink one is having negative charge efficiency. So the charge transfer will take place and then the current will flow in the external circuits. So we can see a current signal in the positive direction. So now it is going to it is going far from both the surfaces, and when again it will try to come back, so again the charge transfer between the positive surface and negative surface takes place. So then negative cycle will get completed. So while continuous contact and separation, we can get an AC output. So this is one of the triboelectric nanogenerator which is based on contact and separation mode. So this was the principle of triboelectric nanogenerators. Now I will show you how it develop. So here we have two surfaces. One is a positive surfaces. So positive surfaces we have taken as aluminium. So aluminium is having a positive charge efficiency on the surface, and then for the negative charge efficiency we have taken a FeP polymer. Then since FeP is dielectric in nature, so to collect the charges from the surfaces we put one copper tape at the back side, and then we have attached some electrical wires so that we can collect that charges during the external from the external circuits. So we have designed this triboelectric in such a way that it maintains its positions. So now you can see this triboelectric nanogenerator. So it is in the separation mode, and once the external load will apply, so it will come in contact, and once this external load will be released, it will again come to our original position, like separation mode. So this is called contact and separation mode, one dimensional triboelectric nanogenerator. So now we will see the performance of this nanogenerator. So now I am connecting the FeP one negative terminal to FeP and the positive terminal to the aluminum. So with now I am going to give some vibration on that, so that I am going to give some contact and separation forces, so that charge transfer takes place. So now you can see. So now if I'm tapping the both surfaces coming in contact, so what will happen? One peak will get generated. So you can see the other peak, and as I will release the both surfaces, another peak will get generated. So you can see while coming in contact, the negative cycle is getting generated, and while coming in, while releasing it, the positive cycle will get generated. So this is how the AC current will get generated with contact and separation mode. So now, apart from contact and separation mode, so we have a sliding TNG also. So both the surface will rub to each other. So again, both in this also we have FeP as well as aluminum, and this both the surface will rub to each other. So we have applied given some spring, so that with continuous vibration and all, there will be a motion between both the surfaces. So why this charge is getting generated? Because there is some texture on the surfaces, both the surfaces. So what is happening? There is a continuous contact and separation between texture on the surfaces. That's why this sliding TNG is giving the performance to us. So the third one is having a three-dimensional triboelectric nanogenerator. So we have different electrode in this one, and there is a ball inside that triboelectric nanogenerator. So if the vibration is getting generated in the three-dimensional, so in this case, so we can get three-dimensional performance of that triboelectric nanogenerators. So now the point is, so where we can use this kind of triboelectric nanogenerator in microrobotics. So one thing is that, so it can be used as small as possible, because if we have taken a sample size of 20 centimeter by 20 centimeter, 2 centimeter by 2 centimeter. So if we can reduce these surfaces to 1 centimeter or 0.5 mm or 0.5 centimeter or 1 centimeter also, then also both this nanogenerator will give performance to us. So the advantage is that in the miniaturized devices also, this triboelectric nanogenerator can give the performance of it. The another advantage of this triboelectric nanogenerator is it can be used as a self-powered. So since it is harvesting energy from vibration energy from environment, so this can be used. So it has a natural tendency to collect the charges from the environment, because once the surfaces become neutral, so the positive charge is coming from environment only, because the surface is having tendency to charge abundance. So it is taking a positive charge from the environment. That's why, so this can be used as a self power. So it doesn't require any external power source. Again, if you see the voltage rating of this one, the voltage rating is coming around to 400 to 500, but the current wise it is giving in the order of few microamperes. So we can say the few microamperes means 20 to 40 microamperes. So but this 20 to 40 microamperes is we can't use for micro devices or Microsoft robotics. So what we can do, we can use some energy harvesting circuit, so that the high voltage is getting reduced to the low voltage, and this microampere will get converted to some milliampere. So by storing this energy in some capacitor bank and using some the energy harvesting circuits, we can use this energy for powering micro devices. So the third advantage of this process is it has a material versatility. So because this can be both the material can be either we can use a soft material and a hard material. The soft material can give us freedom to use in the soft robotics applications. And the third advantage is that these TNGs can be used for different applications. Like if we want to use it as a sensor, then we can use as a vibration sensor, where a lot of vibration available is there. So we can detect the vibration frequency based on the contact and separation mode. Then the same TNG can be used for energy harvesting. The same the same TNG can be used for IoT, developing an IoT module. So our TNG will be act as a sensor, and then this sensor data will get fed to the system. That data can be used to monitor the machine tools. Like if we have a soft robotics and we have attached some TNG on that, so what will happen? The due to the vibration of the soft robotics, soft robots, so this some amount of energy will get generated, and or some amount of voltage or current signal will get generated. So these signals we can analyze based for its perform to see the performance of our soft robotics. So this is how our triboelectric nanogenerator can be used for our micro robotics applications. So another application, if you see from our real world, is that so these triboelectric can be used for harvesting mechanical energy from human motion. So in our lab, what we have developed, like we have integrated this triboelectric nanogenerator in the shoe sole. So what will happen? So there is, you can see there is a two layer of triboelectric nanogenerators. So this triboelectric nanogenerator is placed in the front as well as back. So why? Because when we walk, so we walk like this. So there will be continuously contact and separation, contact and separation. So once the first will get contacted, this will be at separation position. So what will happen? So at one point of time, one TNG will get contacted, and through that we can store, we can get the energy and we can store in some battery pack. So what we have done here, we have harvested that energy from human motion, and then we store the energy in form of battery. So what this stored energy we are using for powering some RFID and GPS module. So we have developed these tools for the soldier applications. So now so another application is that so we have developed one IoT module, so where our TNG is used as a sensor. So on a machine tool monitoring. So let's suppose we have some pretty old machines, so and we don't know when it will get failure. So what will happen? We can attach this triboelectric nanogenerator on the machine tools. So based on the vibration, it will generate some amount of voltage and current signals. So and we can analyze and we can use that current and voltage signals to analyze the predictor for the maintenance of the machine tools. If some part of machine will get failed, so what will happen? The voltage generated from the TNG will get increases. So this is how the TNG can be used for the IoT based systems and all. Thank you.
To test the fabricated triboelectric nanogenerator, we are connected it with an oscilloscope. So by repeated contact separation, we can see we are getting AC voltage peaks of peak to peak of 99 volts. On one side of the removable shoe sole, we have integrated two TNGs with an energy harvesting module which will power a 100 mAh LiPo battery, which is used to power the RF transmitter. This output can be seen on this receiver end. On the other part, we have integrated two TNGs with energy harvesting module, which will use to power a GPS module integrated with Wi-Fi module. These signals will be transmitted to this receiver end. Here the signal will be transmitted over the cloud, so we will be able to see the GPS location over mobile devices. Now these removable shoe soles are packed so that all the electronics and TNGs are secure inside, so that it will be free from the contamination and physical damage. Inside the shoe, we can integrate this shoe sole in such a manner. Now our shoe sole is inside the shoe and it is ready to be wear.
चल दो.
So we have been discussing about the different types of electrostatic configurations. In fact, if you remember, we have also had some discussion about this triboelectric nanogenerators. So these triboelectric nanogenerators are quite an interesting concept. today it is almost competing with the piezoelectric structures. So appropriately we can we can just channelize the charge. So the principle behind this triboelectric nanogenerators are they work on the electrostatic charge principle. So we will be having two material. So one is the tribopositive material and the tribonegative material. The interaction between the tribopositive and the tribonegative will have an impact on the charge which is getting diffused. So with reference to this diffusion of this charge, so appropriately we can channelize this charge. We can use this system for vibration sensing, for condition monitoring, etc. Most preferably wherever there is a need to focus on the low frequency system, there exactly these systems play a vital role. Now let us, as far as these triboelectric nanogenerators are concerned, we will be giving a demonstration about the machine skin. Already we might have given a demonstration about the machine skin, how a triboelectric nanogenerators is used for machine skin related applications, etc. Now let us discuss how these triboelectric nanogenerators can be used for powering these soft robotics, which is made of a kind of a unidirectional dielectric elastomers. So as far as these, we call it as a kind of a TNG based self-powered nanobot, which is mainly made out of a soft actuator. This soft actuator is made out of a unidirectional dielectric elastomer. Okay. Now, as far as these soft robotics are concerned, so these soft robotics and micro robotics go hand in glove for an effective formulation of these structures. So these soft robotic structures are developed by elegantly integrating these soft actuators compliant structures and stretchable sensors. So they have been demonstrated with promising potential in medical operations, underwater manipulations, human assistance, etc. So one of the key soft actuator is this DEA, which we call it as a dielastomer actuator, dielectric elastomer actuator. So these are kind of an emerging class of soft actuators with advantages of having a fast response, high energy densities, and it almost resembles the human muscle. That means it almost has it can withstand a good amount of large strain. So there are different types of such kind of DEAs have been reported efficiently. So as far as these particular case is concerned, so these DEA exhibits a kind of a flexible body, and it also exhibits a kind of a locomotion which we call it as dexterity locomotion. Especially such kind of dexterity locomotions are exhibited in an unstructured environment. Okay, so when we try to use some kind of conventional type DEA, it poses an obstacle for such kind of small scale robotic system. However, these TNG based structures are capable enough of harvesting a kinetic energy from the environment to generate a matching power to this DEA. So this DEA based robot is hindered due to the non-linear and insufficient mechanical transmission in robotic motion. So like there are some case studies where people have attempted using these triboelectric nanogenerators to encash the energy from this unidirectional DEA driven so that it can be effectively used for robotic conjugation system inbuilt using a freestanding TENG. Now let us see how these TENG based robots are structured. So ideally, if you try to look into the overall construction of this, so there will be a kind of a, this is the structure, and then there is a freestanding mode TENG. So this is a kind of a charge which is available, and then it is directly connected to the structure. The structure looks something like this. Where there is a kind of a, this is the kind of a dielectric elastomers. And this is a kind of PET frame, and this is a one-way bearing bell. So this is a kind of a soft robotic structure. So where we have a kind of a dielectric structure which is available, and these dielectric structures are connected in the form of a TENG. So in the proposed system, what we have is, it's a kind of a TENG based, it's a soft robot conjugation system. So in this soft robot conjugation system, a freestanding TENG is directly connected to the soft robot, and the soft robot is composed of a kind of a dielectric elastomer actuator, a compliant arc-shaped body, and the 3 one-way bearing wheels are available. So when sliding the TENG voltage, so like it is something like this, when we have 3-4 different configurations. So one configuration is, so we have the sliding left and the sliding right mechanism. So in the case of a sliding left mechanism, so we have a kind of a voltage off configuration and the voltage decrease configuration. Similarly, we have a kind of a voltage increase configuration. This is the dielectric medium which is available. This is the dielectric medium. This is the voltage increase configuration. And we have the voltage max configuration. Okay, so what is happening is this is a kind of a sliding left, and this is a kind of a sliding right configuration which is available. So what is happening is when the sliding TNG voltage is generated to actuate this DEA, so the DEA elongates and retracts, producing a displacement of the robot. In one sliding cycle, the soft robot completes a locomotion step, and the conjugation step is established in this particular fashion. So the power off and the power max states of the robot showing a forward displacement. Now, as far as in this particular case is concerned, so it almost depicts the TNG bot as a kind of a TNG based soft robotic conjugation system. A freestanding mode of a TNG is designed and connected to a soft robotic structure. Like in the freestanding TNG, the moving component can slide freely on the fixed 2 substrate. Since the mobile layer is an electrode free, it eliminates the electrostatic shield effect that leads to create a high charge in the system. So like the characterization, when we try to look into the characterization of the soft robotic structure, so these kind of soft robotic structures are a kind of a unidirectional structure. So if you closely observe in this unidirectional structure, so these unidirectional structure, So these unidirectional structures go back and forth, and the linear mechanical performance of these soft robotic structures are considered, which is considered to be one of the key characteristics of this robot. Of the soft robot. The relationship between the speed of the robot and the voltage frequency is in the form, like when you try to give a various waveform to this system, so appropriately we can establish the different voltage and frequency of these structures. And then one of the important characteristics of this structure is the response time. So once we look into the response time of these structures, so these response time of these structures play a vital role with reference to usage of this system for different conditions. Now in that aspect, so if we try to look into the performance of it, so these kind of unidirectional soft robotic DEA driven soft robotic structures are concerned, it aligns the direction of DEA in extension with the robotic motion to achieve the high energy efficiency conversion. Okay, it also aligns the DEA in extension with the robotic motion to achieve a payload capacity of close to around 40 grams, because we have a kind of an alternative deflection which is happening over here. So appropriately there will be a kind of a deflection and actuation which exhibits in this particular system. So the TNG bot, that is a TNG soft robotic conjugation system, is built using a kind of a freestanding TNG with benefits from the simple structure and high efficiency of the robot, and the electrical generated by the TNG can directly drive the robot without additional control panels. So like quite a good amount of experiments has been demonstrated over here. So like so I would like to, so this data is from a paper like published by Zhongling Group, so where they have published in Nano Energy. So I'll be sharing that paper in the reference, so where you can go through it, so that this is a kind of a concept in which, so in this particular concept, so in this paper they have proved the concept. Like this concept is quite interesting because these are kind of a self-energized system. So it's a kind of free charge which you are trying to get out of it, and how you channelize these free charges and how these channelized free charges can be effectively used for a micro robotic application. In fact, this is completely a new area which people are exploring, and there are quite a good amount of challenges. If we can address these challenges, then appropriately we can use it for soft robotic related applications. In fact, as an extension of this, we can use this for actuating the piezoelectric structures. Even we can use it for actuating this muscle kind of structures. In fact, we can integrate that triboelectric and shape memory alloy for effective actuation, so that we can reuse, so that these actuated structures can be effectively used for kind of a condition monitoring related applications. Okay, so there will be some video demonstrations related to TENG, so that you will get an idea of it and how you can effectively use for a robotic application that we can discuss through some different case studies, and I will also give you some assignments related to it, so that you can go through some of the literatures and you can report it back.
Hello one and all. This is a triboelectric nanogenerator, also known as TNG. It has capability to convert the ambient mechanical energy into electrical energy. As we can see that by manual tapping on this triboelectric nanogenerator, we are able to generate AC electrical output. It works on the coupled principle of triboelectrification and electrostatic induction. Now, to demonstrate the sensing capabilities of this TNGs, we have mounted one TNG over the air compressor. Now, initially we are getting some minimum noise. As we are turning on the air compressor, you can see that voltage signals are being generated corresponding to that of the vibration generated by the machine and which is being detected by the TNG. And as we are turning off the machine, we are not getting those voltage signals, which shows that TNG has the capacity to detect the working condition of any machine. Now, if we look at these signals, these are mixed signals. These are not just simple sinusoidal curves. These signals tells us a lot about the condition of the machine, or is there any defect in the machine, because if there is any defect or any wearing or tearing is there, we can identify it easily by analyzing this vibrational signal. So we will record this signal and then we will process this signal to understand the vibration characteristics. Now we have collected the data generated by the TNG corresponding to the vibration signal generated on air compressor. So here, as we collected this data, we got to know that the TNG was able to detect the working state of this air compressor. As the air compressor was turned on, we got the signals corresponding to that, and as we turned off, we are not getting any signals. So these mixed signals, we processed it. We applied fast Fourier transform on this signal so that we can detect the working frequency, the vibrations frequency. So here firstly we are getting 24 Hertz of frequency, which correspond to the 1440 RPM of the motor, which is in this air compressor. And we are getting the second harmonic of 48 Hertz and third harmonics of 72 Hertz and so on. Here additionally we are getting a 50 Hertz, which corresponds to the frequency of AC current input in our power supplies. So this demonstrates that it can work very well as a vibration sensor. Now, if we will strategically plan that where a sensor can be implanted so that we can understand the working of the machine or to condition monitor it, because we can understand a lot about a machine by studying the vibration signal. Any near to occurring defect or fault can be detected by the change in the vibration characteristics of the machines. So after mapping the vibration characteristics of any machine, like what kind of vibration is there, whether it is in one dimensional, two dimensional, in plane vibration or perpendicular the vibration, we can implant different TNGs and different location to analyze the entire machine. So this forms a machine skin. So here we have implanted two TNGs, one on the induction motor and one on the hydraulic cylinder part. So here what we are able to see, that firstly, if we analyze the data on the TNG which is implanted on the piston cylinder arrangement, that as the piston is going to the top dead center or at the bottom dead center, we are getting a vibration signals over there because of the vibration due to change in the direction of motion. And if we are adding an external load over the piston, we are getting a voltage signal of higher amplitude. So will be able to understand at what time it is changing its direction and whether it is under external loading condition or not. Secondly, when we are putting a TNG acting as a vibration sensor on the motor, we are able to detect its working state when the motor is being on, when the motor is being turned off, and upon taking Fourier fast transfer FFT on these signals, we are able to get the vibration frequency of 24 Hz, which corresponds to the RPM of 1440. Now, to get this data on our computer, our mobile for remote monitoring, we can integrate an IoT module. As TNG being a good energy harvester, it can act as a self-powering vibration sensor so that it works autonomously without requirement of an external power supply. So when we integrated an IoT module onto it, we can get this data wirelessly on our mobiles and computers and smart devices. Now, firstly, on when TNG was placed on a motor, as it was turned on, we will get a signal of turned on over here, and corresponding voltage signal can be seen on the dashboard as well as the FFT corresponding to it. Now, if some defect is coming on our motor, we will get an additional frequency peak, which will be corresponding to that defect. Normally, we won't get those difference in the FFT signal or change in the pattern of the voltage values, but whenever there is some abnormality there, an anomaly can be detected in this signal or the FFT of this signal. Then secondly, when the piston on the piston we have integrated the TNG, we can detect when it is moving up, when it is changing its direction and moving in the downward direction. In this way, we are able to condition monitor the entire machine wirelessly without requirement of any external power supply. So these TNGs are very helpful as a power source and also as a sensor for vibration sensing application, pressure sensing application, and proximity sensing application in micro robotics.